Hey guys, and welcome back. So in this video I'm going to speak about trigonometric ratios and right triangle, but before I start, please make sure to subscribe to my channel, turn on the notification button, and stay tuned for more videos. So basically guys, I'm going to start by the definition of a right triangle. So right triangles are special triangles that have a 90-degree angle. As you see in this particular example, and if you look at angle C, it's clear that angle C is a right angle and its measure is 90 degree, which means that this triangle is right. Also guys, in right triangle, we call the side that facing the right angle as hypotenuse. So in my particular example here, it's clear that AB is facing angle C. For this reason, I call it as the hypotenuse. And we call the other sides or the adjacent sides to the angle, to the right angle, as leg 1 and leg 2. So these are the legs, and AC and CB in this example are the legs, and AB is the hypotenuse. Trigonometric ratios are special ratios that are applied only in right triangles. So guys, before you start using trigonometric ratios on any triangle, you have to make sure that the given triangle is right, or we cannot use this trigonometric ratios. I'll start by defining the first ratio, which is sine angle A. For example, here I chose angle A. If you want to find the sine angle A, it's defined by the opposite of angle A divided by the hypotenuse. Opposite of angle A, I mean the opposite side. If you look at this given triangle, it's clear that CB, segment CB, is opposite to angle A, and AB is the hypotenuse. So simply here, sine A is equal to CB divided by AB. In a similar way, guys, we can define the cosine of angle A by the rule adjacent of angle A divided by hypotenuse of angle A. If you look at this diagram, this is angle A. It's clear that AC is the adjacent side and that AB is the hypotenuse. So simply here, cosine angle A is equal to AC divided by AB. And finally, tangent angle A is equal to opposite of angle A divided by the adjacent of angle A. And in my particular example here, it's equal to CB, because it's the opposite side to angle A, divided by CA, which is the adjacent side to angle A. So basically guys, these are the three important trigonometric ratios that can be applied in a right triangle. Of course, we have other trigonometric ratios like cotangent A, secant A, and cosecant A. But in fact, guys, we can deduce the values of these ratios because we have a good relation, like we have exact relations between the previous ratios, in which cotangent A, it's simply 1 over tangent A, so it's the reciprocal of tangent A, while secant A is the reciprocal of cosine A, so it will give 1 over cosine angle A. And finally, cosecant A is the reciprocal of sine A, so it will give 1 over sine angle A. Now guys, let us try to find the trigonometric ratios for a different angle. Yeah? For example, if I want to find the trigonometric ratios of angle B, I'll say that sine B is simply equal to opposite of angle B divided by the hypotenuse. And it's clear here in this example that the side that is opposite to angle B is side AC, so it will give AC divided by AB. And guys, if you go back to this rules here, it's clear that AC over AB from this rule, it's equal to cosine A. So in general, in a right triangle, cosine A is equal to sine B, or sine AB is same as cosine A. Now same thing guys, let me try to find cosine angle B. Cosine angle B is equal to the adjacent to angle B over hypotenuse. The side that is adjacent to angle B is CB and the hypotenuse is AB. So simply it's equal to CB divided by AB, which means that it's equal or it's same as sine A. If you go back guys to the box, here sine A is equal to CB over AB, and also cosine B is equal to CB over AB. So also in a right triangle, cosine B is equal to sine A. And also, if you want, tangent A is equal to cotangent B, because cotangent B or tangent B A is equal to CB over AC, while cotangent AB is equal to AC over CB. So tangent A is 1 over tangent AB, 1 over tangent angle B, and it follows that it's equal to cotangent B by the definition of cotangent that I give it before. Now finally, let us speak about the right angle C. Right angle C, guys, is special because it's the right angle, so I'll give some facts about the angle C without applying these rules, in which sine angle C, since it's 90, so it's equal to sine 90 and it's equal to 1. Cosine angle C, which is equal to cosine 90, which is equal to 0. And finally, tangent angle C, which is equal to sine 90 over cosine 90. So it's 1 over 0, which means that it's undefined. So as you see, guys, tangent of any right angle is undefined. And guys, these are always true for any right angle. Whenever you have a right angle, sine of the right angle or sine 90 is 1, cosine 90 is 0, and tangent 90 is undefined. Now please, guys, check my next video because I'm going to solve particular examples about how to use the trigonometric ratios. Thank you for watching, guys. See you later.